Hello everyone and welcome to the lecture on built-in functions on sets. In the previous lecture we saw how to create sets by using the set built-in method and passing elements. For instance, we can create a set and then store the values in a variable called C. So C is equal to set. That will create an empty set C. We can call our set, and we saw one function called the add function. So c.add, and then we can add elements to our set. Let's say we add the element 3. Now if we call C, we have a set containing the element 3, and then to add more elements we can call the add function c.add, and we can add, let's say, 4, and similarly we can add c.add, let's say 5. If we call C, we have a set containing the elements 3, 4, and 5. And to see the available built-in functions, we can simply say C dot and then hit tab on your keyboard, and you'll see a list of methods available on sets. So we'll try to see most of these methods. Okay. So let's start with, we already saw add. Next, let's see the copy method. Let's copy our set C. So c.copy, and then we'll save it in a variable called D. Now if we run it and then call our D object, we have 3, 4, and 5. And we can add elements to our new set D. So c.add, let's add the number 6. If we call D now, we have the elements. We have a set containing the elements 3, 4, 5, and 6. Now let's look at some methods that we can do, some built-in methods we have on sets. One such method is the union method. So as the name implies, the union method will give us the union of two sets. For instance, so to use the union methods, we have our two sets C and D. So C dot union, and then we pass our second set, which is D. So that will give us 3, 4, 5, and 6. If we check the reverse, we'll get the same result, which is D dot union, and then pass our list, our set C. We get the same result. So the method union gives us the union of both sets. So all the elements in both sets will be displayed. And that takes us to another method known as the subset. So we'll check the is subset, and there's another method called superset. We'll look at those two methods next. So D dot, let's say, is subset, and then we pass our second set C. So this will give us a Boolean result, true or false. In this case, D dot is subset C will be false. Subset means all the elements in one of our sets are in the other set. In this case, are all the elements in our set C. Let's call D first. So D is 3, 4, 5, and 6, whereas our set C has the elements 3, 4, 5. So D is D subset of C. Are all the elements in D included in C? No, because of this last element. So this will result false. So we get false. Whereas the superset method, if we check if our set C is a subset of D, that will be true. So C dot is subset, we pass D, that will be true. Now let's look at the superset method. So C dot is superset and then D. So superset is the opposite of subset. In this case, D is a superset of C, but C is not a superset. So this will return in false, whereas D is superset of C will be true. Okay, superset is the opposite of subset. Next, let's look at the intersection method. So C dot intersection, then we'll pass D. So this will give us elements where the two sets intersect. In our case, it will be 3, 4, and 5, right? Intersection means common to both sets. Similarly, if we do D dot D intersection of C, we get the same result, 3, 4, and 5. Next, let's look at the difference method. So we have C dot difference, then we'll pass D. So the difference method will give us elements that are missing in the second set. So in this case, C dot difference is the difference between those two sets is the element 6. So C dot difference. So C dot difference D will give us an empty set. That's because the elements in C are not different from D, whereas D dot difference C gives us 6. That's because 6 is not in our set C. So the results are different if we check C dot difference, the second set, and then the second set dot difference, the first set, unlike the other methods like union and intersection. So that's one thing to note. Okay, let's call our two sets, C and D. And next, let's look at the difference update method. So D dot difference underscore update, and then we pass C, run it. So what this will do is that it will get the difference and then update it to our set. Here, our set D contains the elements 3, 4, 5, 6, and our set C contains the elements 3, 4, 5. And once we apply the difference update method, and if we call our set D, it has the element 6, whereas if we call our set C, we have 3, 4, 5. So what this method does is it takes the difference of the two sets and then updates the set with the difference. So that's what the difference update does. Now we have D as 6 and then C as 3, 4, and 5. Let's look at another example. Let's create two more sets. Let's say I. We save the first one in I, okay? The set. Let's use the range function, range, let's say from 4 to 10 in step sizes of 2. So if we call I, we have 4, 6, and 8. And let's create another set, I, let's call it J, set range 4, let's say 4 through 8. If we call J, so J has 4, 5, 6, and 7, whereas I has the elements 4, 6, and 8. So if we do I dot difference update and then J, the element that's only in I is 8, right? So if we apply this difference update on I, it will update our set I to only contain the number 8. So if we run this and then call I again, so now our new set only has the element 8, whereas J still has the elements 4, 5, 6, and 7. Let's add some more elements. Let's say I that add, let's add 6. If we call I now, we have 6 and 8, right? And if we do J dot difference update I, in this case, so J and I, the numbers or the elements 5, 7, and 4 are unique to J, right? 4, 5, and 7. So it will update our set J to contain those elements when we call this difference update method. Okay, so if we call J now, we have 4, 5, and 7. Great. Next, let's look at the symmetric difference method. So this symmetric difference will remove all the intersection elements, all the elements common to both of the sets. Okay, let's add some more elements to our set J. J dot add, let's add 6. So now J has 4, 5, 6, and 7. How about I? I has 6 and 8. Let's add one more element to I. I dot add, let's add 7. Let's call I. Okay, I has the elements 6, 7, and 8, whereas J has 4, 5, 6, and 7. So now, let's see the symmetric difference method. I dot tab and then symmetric difference. I dot symmetric difference and then J. So this symmetric difference gives us elements that are not common, that are not found in both sets. So basically this is the opposite of intersection, right? So J has 4, 5, 6, 7, and set I has 6, 7, and 8. And these three elements, 4, 5, and 8, are unique. That means not found in both sets. That's because 4 and 5 are only found in our set J, whereas 8 is found in our set I. So that's the symmetric difference method. Similarly, if we do J dot symmetric difference I, we get the same result, 4, 5, and 8. And this takes us to another method called the symmetric difference updates. So what that will do is it will update the set with the symmetric difference elements. So if we apply I dot symmetric difference update J, it will take these elements 4, 5, and 8, and it will update our set I so that it contains these three elements. If we run this and then call our set I, it now has the elements 4, 5, and 8. And J still has its previous elements 4, 5, 6, and 7. Now, if we see the symmetric difference between our two sets I and J, J dot symmetric difference I, that will give us the elements 7, 6, 7, and 8. Let's run it. 6, 7, and 8. And now if we do J dot symmetric difference update I, now our set J will be updated to contain the elements 6, 7, and 8. So if we run it now and then call J, it has the elements 6, 7, and 8. So that's the difference between symmetric difference update and symmetric difference. Symmetric difference will give us the elements unique to the sets. That means elements not common in either set. And the symmetric difference update will update our set with those unique elements. And similar thing happens with the difference method and then the difference update method. The difference update method will update a given set with the difference. Next, let's look at the discard and remove methods. So as the name implies, both discard and remove methods remove an element from our set. Discard and remove. The only difference is the remove method will throw an error if the element does not exist in our set. Let's look at an example. So our set J has the elements 6, 7, and 8. So we can simply remove the element 8 from our set. You can say J dot remove. So we can remove it by using both remove and discard. So J dot remove, let's say 8. And now if we call J, our set only has the elements 6 and 7. Let's try to remove 8 again. So J dot remove and then pass 8. So right now 8 doesn't exist in our set, so this will throw an error. So if you run it, you'll get a key error. Okay, now let's look at the discard method. Let's call our set I. I has the elements 4, 5, and 8. Let's do the same thing. Let's remove 8 by using the discard method. So I dot discard and then pass 8. Now if we call I, we have a set containing the elements 4 and 5. If we try to remove I again, if we try to remove 8 again by using the discard method, since 8 doesn't exist in our set and we are using the discard method, so we'll not get any error. If we run it, nothing will happen, no errors. If we call I again, we'll get a set containing the elements 4 and 5. So that's the difference between discard and remove. Great. Those are most of the built-in methods that we have on sets. Thank you everyone, and I'll see you at the next lecture.